Aliasing is a phenomenon in pulse Doppler echocardiography in which the direction of flow is depicted as opposite. Here, this is the forward flow in the aorta. This is the reverse flow due to aortic regurgitation. Beyond a limit, this is the Nyquist limit, just beyond 200 centimeters per second is the Nyquist limit set in that particular examination, and beyond that it is cut off. The Doppler tracing is cut off and the remaining part wraps around. This is the wrap around. Actually, this should have come here. If you increase this velocity much higher, this will come here like this. This phenomenon is seen only in pulsed modes of Doppler, low pulse repetition and high pulse repetition. In continuous wave, as the imaging is continuously done, Doppler evaluation interrogation is done continuously, there is no Nyquist limit, which is almost infinite. So this does not occur in continuous wave Doppler evaluation. You can change this in different ways. You can increase the Nyquist limit by increasing this, or sometimes you can get over it by changing the baseline. Now the baseline is here. If you want to see this more, you can bring the baseline down. So the upward Nyquist limit will increase, downward Nyquist limit will be lower. So if you bring it down, this jet will get cut off. This forward flow in aorta will get aliased. Similar Nyquist limit is there for color Doppler also. You can see that the Nyquist limit for the blue flow here is shown as minus 77 centimeter per second. This is blue flow because this goes down into the aorta away from the transducer located here. This is the mitral flow directed towards the transducer. It is seen as red. Flow away from transducer is coded blue and flow towards the transducer is coded red. That is the usual notation. And here also color wraparound can occur if the velocity here exceeds 77 centimeter. Then this can change into red color, that is color wraparound, similar to the wraparound seen in the other Doppler echo seen earlier. This is another image from the apical 5-chamber view. 5-chamber because aorta is also seen here. Aorta is considered as a chamber in this view. The other chambers are right ventricle, right atrium and left atrium. You have the forward mitral flow towards the transducer, and that is coded red. And you can see that Nyquist limit is minus 75 for blue flow and plus 75 for red flow. So this is within that limit, so it is seen as red flow. And here you note that the color bar, that is the showing the Nyquist limit, is on the opposite side. In some machines it will be here, in some machines it will be on this side. Even during same recording, you can have two different Nyquist limits. See, here it is minus 63 for color Doppler. That is for color Doppler, 63 centimeters. This is different from the Nyquist limit for HPRF. In HPRF, the upward is beyond 4. This is 4 meter per second and this is 63 centimeters. If you look carefully, you can see a point here. That means this is 63 centimeters per second, while this is meter, much higher. And depending on the baseline setting, you can increase in the upward direction or downward direction. This is 5-chamber view showing the aortic flow. Both aortic regurgitation jet and aortic stenosis jet are seen. But because of the higher settings, there is no aliasing seen for the aortic regurgitation jet. The whole jet is seen here. and this is the VTA tracing, velocity time integral. All these values are shown here. Aortic valve velocity time integral, and this is measurement of the pressure half time. You can see that pressure half time is shown here. Then deceleration time, AR deceleration slope, all these values are taken from this. So in this image, there is no aliasing for the aortic regurgitation jet or aortic stenosis jet. The forward gradient is not much, it's only 31. So aortic stenosis is not that significant. There will be increase in gradient when there is aortic regurgitation. So this is in short about aliasing and Nyquist limit. Nyquist limit is half the pulse repetition frequency. So it will be low for usual pulse Doppler, but higher for HPRF or high pulse repetition frequency. That is because Nyquist limit is half the pulse repetition frequency. In CW or continuous wave, it is infinite. There is no Nyquist limit.